factorial, the factorial, and we will be using an exclamation point. That's our symbol for factorial. That says to multiply all whole numbers down to 1. The algebraic definition can be written as n factorial equal to n times n minus 1 times n minus 2 times n minus 3 all the way down to 3 times 2 times 1. We will agree that 0 factorial equals 1. Now let's apply this process to a number. So here we have model B. Use the algebraic definition of a factorial, and here I wrote it down, in order to expand the given number. The given number is 7, so we're going to expand 7 factorial here. This is my recipe. I'm going to follow this recipe with this given number. So here I don't have n, I have 7. I have 7 factorial, and I'm going to copy this recipe. Everywhere I see an n, now I'm going to replace it by a 7 instead. So here I have 7 times, I'm going to be using the point as instead of the cross for now. Then I have 7 times 7 minus 1 times 7 minus 2 times 7 minus 3. For this example, I'm actually going to be able to expand a little bit more. Here it only went up to 3, but for 7, since it's a bigger number, I can keep going. I'm going to be doing 7 minus 4 times 7 minus 5 all the way to 7 times 7 minus 6. And I know it may seem a little bit strange for now, but in a few moments, in a few seconds, you're going to see that this is basically this pattern right here. Let's begin by simplifying all of this stuff here. So we have 7 times, well, 7 minus 1, that's going to be 6, times 7 minus 2, that's going to be 5, times 7 minus 3, that's going to be 4, times 7 minus 4, that's going to be 3, and then times 7 minus 5, which is 2, and then times 7 minus 6, which is 1. And here you can see that tail, 3 times 2 times 1. This part right there. Hence, we have that 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. This is the formal recipe here. And after you've done this recipe for a couple of times, you'll see that it'll be automatic. You won't have to do this process. You will just see that this written version can suffice, right? We're just going to multiply all whole numbers down to 1. So if I have 7 factorial, I'm going to begin with 7 and multiply all whole numbers down to 1. There are advantages for having this mathematical definition, and I'll apply it towards the end of the class to show you why 0 factorial equals 1. But trust me, there's a reason why we have both definitions, both algebraic and both this written version as well. So here let's apply the more straightforward version. If we expand 13 factorial, I'm going to begin with 13 and multiply all whole numbers down to 1. So times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is the expansion of 13 factorial.